Okay guys, so if you're watching this video, you should have already watched video 1, which was the density of beverages data collection video. You should have opened a file that looks very similar to this in Google Sheets. Now, you should have entered these values for mass from the video. However, your numbers will look different than my numbers. My numbers are made up just to walk through a sample calculation, okay? Do not use my numbers. If you use my numbers, you will get a 0 and have to redo the lab. Watch video 1, fill in this information from video 1, it will look different, okay? Once you've filled in these numbers, you should have calculated density for all of the solutions here. Just a reminder, when we calculate density, density is equal to mass, which is this value here that you got from the video, not mine, but the one you got from the video, divided by your volume. Now, if you notice, volume for every single trial is always 10 milliliters. So you're going to take your mass in grams, divide by your volume, which is always 10, to get your density, which you will then round to the correct number of significant figures. As you enter these numbers into your computer, you should start seeing a graph form over on this right side, okay? Now what this graph is called is this type of graph it's called a calibration curve, okay? Now what a calibration curve is it's a situation where we take something that we know and we use it to determine something that we didn't know. So in this case, I had 5 solutions that I knew the percent of sugar in, okay? So my graph has only those 5 solutions, the ones I did know the percent of sugar in. I'm going to take my values down here with my density for my unknowns, and I'm going to use my calibration curve for the knowns to figure out the percent of sugar for Hawaiian punch and apple juice, okay? So here's the way that this is going to work for my calibration curve. As you plot your points, it's going to create this line of best fit, a line that most accurately matches up to all of your data points. And it gives you an equation. Now in math class, you probably remember that the equation for a line is y equals mx plus b, okay? In this case, y is my y-axis, which is density, okay? M is always the slope of our line, rise over run. X is our x-axis, which is percent of sugar. And then B is our y-intercept. So what we did here is we said, okay, what's the relationship between density and percent of sugar, and can we figure out the line of best fit? So I have my line, or I have my equation for my line. Now, remember, yours will look slightly different because mine is based off of my numbers, which were made up. So I'm going to take this equation and I'm going to rewrite it down here. So density is equal to 4.2 e negative 0, 3, little star x plus 0.991. Okay? Now, this number looks really weird. What this is it's the computer's way of writing out scientific notation. So what this actually is 4.2 times 10 to the negative 3. These two values are the exact same thing, okay? So I can either enter this just like this into my calculator when the time comes, if I know how to do that, or I can rewrite this into a number that's easier to work with. We're going to spend a lot more time with scientific notation later on. Quick review, hopefully this looks a little bit familiar. The negative 3 tells me that I moved my decimal 3 places. Because it's negative, I need to make my number smaller. So I move this over 1, 2, 3 places to the left. Okay? Because there were no numbers here, I need placeholders. I'm going to put in zeros. So what this looks like is 0.0042. I don't need to write this times 10 to the negative 3 anymore. I already took care of that when I moved the decimal place over 3 points. Okay. The star is telling me I'm multiplying that number by x, and I'm adding that to 0.991. Okay. Now the density is going to come from up here. I'm going to use the density for my Hawaiian punch. Remember, your number will look different. And I'm going to bring that down here. So I've got 1.03 is equal to mx plus b, where I'm solving for x, where x represents my percent of sugar. Okay? At this point, it's just a simple algebra problem where I'm solving for x. So the first thing I need to do to get x by itself is I need to get rid of this value here. Right now I'm adding. The opposite of adding is subtracting. Whatever I do to one side, I have to do to the other. So when I plug this into my calculator tells me that this is 0.039. Okay? But here's the problem. We started talking about sig figs in the last video. They haven't gone away. This number here is my calculation for density. Density is based off of measurements. So I need to make sure I'm keeping track of sig figs for all of my calculations. And it's limited by my measurements. When I subtract, the rule is look at numbers after the decimal. I've got 1, 2 numbers after the decimal in my measurement, so I can only keep 1, 2 numbers after the decimal in my calculation. Remember, addition and subtraction is numbers, not sig figs. 1, 2, I cut that off there. Because the 9 is greater than 5, I'm going to round up. So this becomes 0.04. So 0.04 is equal to 0.0042x. I still need to get x by itself. So the opposite of multiplication is division. So that goes away. Whatever I do to one side, I have to do to the other. So when I plug this into my calculation, or my calculator, what I get is 9.52857, blah, blah, blah. Okay? Now, again, because I am basing this off of density, and density is based off of calculations, I still need to keep track of significant figures. This time, I'm dividing. The rule for addition and subtraction was numbers after the decimal. The rule for multiplication and division are significant figures. Now, if I think back to my rules for sig figs, I have a decimal, okay? So my decimal is present, P present. I start on the Pacific Ocean side. I don't start counting significant figures until I hit my first non-zero number. This one has, oh look, just one sig fig. Down here, decimal point is present. I start on my Pacific Ocean side. I don't start counting until I hit my first non-zero number. I read all the way to the end. This one had 2 sig figs. However, unlike subtraction, I care about sig figs. I keep the smallest number of sig figs. I can only keep 1. So 9.52, shoop, I cut it off there. Because this is a 5 or higher, I round up. This becomes 10%. And that's the number that I'm going to write in here. Okay. Now, just a reminder again about significant figures. I said I could only keep 1 sig fig. And yes, this only has 1 significant figure because no decimal. My decimal is absent. So I start on my Atlantic Ocean side. I don't start counting until I hit my first non-zero number. Because there is no decimal, this has 1 sig fig. 1 sig fig here. My percentage is about 10% sugar. Okay? So go ahead, use your numbers. Make sure you calculate your percent of sugar for Hawaiian punch and apple juice. Remember, you're going to do this with your numbers from the video, not mine, so this will not be exactly the same. Once you have filled out both this column, and this column into the computer, okay, then you can submit your assignment for points.